Okay, so let's start from number 22, section 4.2. So section 4.2, and the very first one we have number 22. And for number 22 and 23, we are asked to sketch the graph of each function. So our function is g of x equals to negative 3 times e to the power x plus 2. So this is our function. We have to label the y-intercept and a few other points giving their coordinates. Determine the domain and range and describe the behavior of the function as x goes to positive infinity and negative infinity. Okay, at first, what type of function is this? What do you think? Do we know the name for this function?
Like a logarithmic function?
Uh, in the logarithmic function, we see log. We didn't have log here.
Oh, never mind. Sorry. There's just an E. Never mind. Thinking of
Now
ln.
here, our variable is in the exponent, like our input or the variable is in the exponent, right? So this is our exponential function. And if we have exponential function, now the base for this exponential function is e. So our basic function will be, you need to use the transformation, okay? On your exam, you will be asked to use the transformation to graph this function. So you are not finding the list of point and plotting, you are using the transformation. So in order to use the transformation, we need to know the basic function, okay? So this is our exponential function. So our basic function is y equals to, so base is e, so base remains same and e to the power x. So this is our basic function. Now let's graph our basic function. Now how does the graph of this function looks like? So this is our x-axis, this is our y-axis, we have origin, and our function for the exponential expression looks like this, right? Now, what is our y-intercept here? So how do we find y-intercept for this function? We substitute 0 for x. So if this x is 0, we have e to the power 0, and e is a number, right? 2 point sum. So the e to the power 0 is 1. Our y-intercept is 1. So we have this point as a 1. Okay, so this is 0, 1. Now, from this basic function, we need to get this function. Okay. And I think yeah, in section 2.8, we did this transformation. And you don't really need to worry about the stretching, horizontal stretching and vertical stretching. Okay, like we have negative 3 in front of e to the power x. So let's not worry about that. Now, the next we have plus 2 here. Now, how do we get positive 2 in this basic function? Like, what do we have to do?
Move the graph up 2.
Yes, so we lift or we move our graph by 2 units, right? Since if we are adding any number to a basic function, now this is our basic function, y equals to e to the power x. Now you add a 2, and whenever we add a 2, we've shift our function vertically up by 2 unit. But before that, we have a negative here. Okay, before adding 2, we have to multiply by negative 3. Okay, or by negative. The reason here, if you add 2 and when you multiply by negative later, you will have a negative 2 here, and that's not what we want. So before adding 2, let's multiply our basic function by negative 3. Okay, so we have y equals to negative 3 e to the power x. Don't worry about this 3 now, but we have negative. Now, what happens when we multiply our function by negative number? Like what kind of transformation do we see in the graph? So what kind of transformation do we see?
Inverted, right?
I'm so can you repeat that?
It's inverted.
There will be a reflection. Will it be reflection across x-axis or y-axis? So when we multiply by our negative x,
X-axis.
so we reflect along x-axis. Okay, now what the graph looks like when we reflect this graph along x-axis. Okay, reflecting means you just imagine that you have mirror along this x-axis. Now if you have mirror along x-axis, how your graph looks like? So we have it just
Opposite and go downward.
yes. So our next so we have the graph. It reflect. Okay, so this point will be -1. So when you multiply your function by any negative number, then there is a reflection across x-axis. Okay, now we have this. Now we need +2. Now let's add +2 in this -3e to the power x. Okay, and when you add +2, you move this function, you move this graph 2 unit. Okay, so this is 1 unit, this is 2 unit. So let me call this as 2. So how okay, now your y-intercept will be 2 unit above. Okay, so we are here, our y-intercept is here. Okay, so our y-intercept is here. We are moving 1, 2. So we want this point to be here. So how do we draw a line here? Okay, so let me draw horizontal line at 2 so that it would be easy for us to draw a graph. So you draw a graph exactly same, but you are just shifting 2 unit above. Okay, so this is the graph for our function y equals to -3 to the power x plus 2. Does anyone have any question here? Now, if we have this graph, what will be the domain for this function? We have the graph, and finding a domain for a graph means like how far you can extend your graph on the left, from left to right. Like on the left, how far can we go? How far can we extend this graph? All the way,
Negative infinity.
yeah, -infinity, right? And on the right, we can extend all the way to the positive infinity. So from -infinity to positive infinity is our domain. And we also need to find the range. And range is the y values that this graph take. So for range, you look how far you can extend your graph up and like towards downward. Now, on the left side, okay, Nacho, did you say anything? I didn't hear. Okay.
No, I,
Okay, so on the left, like if we extend this graph on the left, this graph, we can extend all the way to the right, but it never crosses our horizontal line. Okay, it never crosses our horizontal line too. It means this graph can have a number very close to 2 but not equals to 2, and on the right side we can extend all the way to the down. Okay, so from +2 to all the way negative, sorry, that's not how we write the in interval notation. So from -infinity to +2, and 2 is not included. Okay, it means when you extend this graph never touches this horizontal line at 2. So from negative infinity to positive 2, excluding 2 is our range. Okay, does anyone have question here? Okay, now from here, can you tell me, do we have any asymptote like a horizontal asymptote or a vertical asymptote? Do we have
Yeah.
any? Okay, what do we have? Horizontal asymptote or vertical asymptote?
Horizontal 2.
Okay, okay. How do we write the horizontal asymptote? These are the line, okay? So whenever you are writing a line, it has to be in an equation. So we have a horizontal line at 2. So that is our horizontal asymptote. And the equation for horizontal line is y equals to 2. Make sure you are writing an equation. So if you write 2, that's not the equation. That's not the horizontal line. And we don't have no vertical asymptote. So no vertical asymptote. And you'll have one similar question, okay? So it means you will be given a log function or exponential function, and you will use the transformation to graph the function. You will be asked to find the domain range, and you will also be asked to write down the horizontal asymptote and the vertical asymptote. So this is one type of question that you have to practice. Okay, now number 23. It's a transformation, okay, but a different function. So let me write on the function. So our function is g of x equals to 2e to the power minus x plus 1. Now this is also exponential function, very similar to the one that we just did, but here we have negative x in the exponent, okay? Now, what does it mean? Like, what is the transformation if you have a negative x? What do we do in the second stage? Like, you start from your basic function. So your basic function is y equals to e to the power x. So this is the graph. So this is the graph for y equals to e to the power x. Our y-intercept is 1. Now, from this basic function, how can we get negative x? We have positive x. How can we get a negative x here? What do we need to do? Does anyone recall chapter section 2.8?
Get negative x.
So we replace this, okay, so we replace this positive x of our basic function by negative x. Okay, you are replacing. So you replace x by negative x. So we have y equals to e to the power minus x, and you can just multiply by 2. It's a stretching, so it really doesn't matter. Now, if you are replacing x by negative x to a function, how the graph transform? Like, what is the transformation here? Now, in previous case, so we multiplied our function by negative. When you multiply your function by negative, we reflect along the x-axis. Now, if you are replacing x by negative x, we are reflecting our graph along y-axis. Now you just consider that you have a mirror along this y-axis and you reflect your graph. So what the graph looks like? Does the graph looks like this? Okay, this is the graph. Now you have to add 1. So adding 1 means you are moving this graph vertically up by 1 unit. So this is 2. So your y-intercept has to be here. And horizontal line will be, so we had horizontal line at 0. Now your horizontal line is at 1. So your graph looks like this. So this is our g of x. Now for this g of x, what is the domain? We can extend on a both side from left to right. So all real number. What about the range? What is the range for this graph? Now, what are the y values that this graph takes when you extend on a both side? Now, if you extend on the right side, this graph, it never crosses this horizontal line at 1, okay? So it means we can't have a graph below 1. But when you extend the graph on the left side, we can go all the way up. It means our range is from +1 to +infinity. The graph does not toss the straight line at 1, so 1 is not included. So use parentheses, and this is our range. The next, what about the horizontal asymptote and vertical asymptote? Do we have any? We do have, and our horizontal asymptote is, we do have horizontal asymptote at 1. So y equals to 1 is the horizontal asymptote. Okay, and we were also asked to write the end behavior as x goes to +infinity and -infinity. Okay, now here, like for this graph, so when your x goes to infinity, it means when you extend your graph all the way to the right, what happened to your function g of x? Who can tell me here? So whenever you are extending your graph all the way to the right, what happens to your g of x? Like what happens to the value of y, where it goes? Where it goes, like if you extend all the way to the right.
It gets infinitely closer to 1.
Yes, the g of x is very close to 1, not equals to 1, but the g of x is very close to 1. Okay, now when you extend your graph on the left, it means when x goes to approaches -infinity. So when you extend this graph on the left side, our y coordinate, okay, which is g of x, our g of x, so it goes all the way to the up, means it goes to +infinity, and these are the end behavior for this graph. Okay, so if you are asked to write down the end behavior, this is how you're gonna write. And as I said earlier, you will have one type of this question, okay? And in our, I think next section, there is a log function, and you might get a log function, you might get exponential function, but out of log function and exponential function, you will get a one function. You have to graph that function using a transformation. Okay. Now let me know if you have any question before I start the next one. Okay. Now the next is 27 and 28. So in 27 and 28, so there is an initial deposit of $1,500. So deposit, that is our principal, which is $1,500. So you deposit initially $1,500, and you are asked to find the amount in bank account. So you are asked to find amount which is unknown after 6 years. So our time is 6 years for the interest rate and compounding frequencies given. So in number, okay, hold on, let me read it one more time. Initial deposit is 1,500. Find the total amount in the bank account after t years. Okay, for 27, our t is 4, not 6. So our t is 4 years, and the interest is, okay, continuous compounding of interest rate 8%. So there is a continuous compounding. Okay, you look for the keyword continuous. So that's the keyword here. So continuous compounding. Okay, and the rate is given to us is 8%. We write our rate in a decimal, 0.08. Now, if we have a continuous compounding, what is the formula to calculate amount? Is it, I may be wrong. Is it P time e to the power RT? Or I need to let me double check. Okay, does anyone recall the amount for continuous compounding? The formula to find the amount when we have the interest continuous compounding.
I think
Yeah,
that's
that's right.
Okay, now if we have the formula correct, then the remaining is super easy, right? You substitute. So your P is 1,500, your E is a number, your R is 0.08, time T is 4. So our remaining You can do it using your calculator. And in 28, the interest is 3.5 and time is 5. And you are asked to use the continuous compounding. Okay, so whenever you have continuous compounding, you're going to use this formula. Okay, and if there is not continuous compounding, like in 25 and 26, I didn't mark that as a review, but just let me do one, okay, just in case. So we have 25. Principal is given as, it's the same principal. The deposit is $1,500. Time is 6 year, and we need to find the amount for the interest 6%. So our interest is 5%. So our rate is 5%, which is 0.05, and it is compounded quarterly. Now, if it is compounded quarterly, we have to find n. So what will be the n when the interest rate is compounded quarterly? So n is the number of times interest is compounded in each year, okay? Like in how many quarter you can divide 1 year? So that's a 4, right? Or is it 3?
I think it's 4.
Okay, so our n is 4. So if it is compounded quarterly, it's n 4, okay? So if it is compounded annually, what will be n? N will be 1 if it is annually, okay? So if we have semi-annually, our n will be 2, okay? If our interest is compounded monthly, we have 12 months, so n will be 12. If our interest is compounded daily, it will be 365, okay? So we have compounded quarterly, so our n is 4. And the formula to find the amount is P time 1 minus, is it N over R to the power RT? Just correct me if I'm wrong. The formula will be provided to you. Or is it R divided by N? I think it should be R divided by N, right? Does anyone recall here? I'm thinking so it should be R divided by N to the power R. Is it RT or NT?
Yeah, it's R.
Is this
NT
correct?
is the exponent.
Okay, NT is the exponent.
Yeah.
Okay, thank you. And it is R over N, right?
Yeah.
Okay, thank you. Now the remaining you substitute. P is given, R, N, so everything is given. Does anyone need help in calculating from here? Okay, it looks like a no. So I'm gonna skip the remaining, okay? So, and this formula will be provided to you, but make sure to choose the correct formula. You're gonna choose this only if you see a word continuous, okay? Otherwise, you're gonna use this formula to find the amount. And when compounded annually, n is 1. It won't be given to you. When it is semi-annually, it is 2. When it's monthly, 12. When it's daily, 365. When it's quarterly, it's 4. Okay. Now, I think we are done with section 4.2. Now, let me go to section 4.3. So, section 4.3. Okay, in section 4.3, we 31, 32, 33, 34, 35. Okay. From 31 and 32, you will have one question. I mean, you will have two questions. You will be given a log statement, and you will be asked to convert into exponential. In the similar way, you will be given an exponential statement, and you have to convert into logarithmic statement. Okay, so let me do one. So in 31, we are given with log of 9 to a base 3 equals to 2. So to convert this into exponential statement, you just write down whatever with you have with the log. So we have 9. So 9 equals to base remains same. So we have base 3. So you will have base 3 on the right side. And whatever you have on this side, right side will be the exponent. 9 equals to 3 square. This is the exponential statement. And remaining, you should be able to convert. Okay. And you'll have one problem where you have to convert log into exponential and exponential into log. And let me do one from number 32. So we are given 4 to the power 1 over 5 equals to 5th root of 4. Okay. And we are asked to convert into log. So we are converting into log. So where do we start from? So we start from the exponent. Exponent equals to, so exponent is 1 over 5. So exponent equals to, since we are converting into logarithmic statement, we need to have a log. Okay. The base will be same as the base in the exponential statement. The base we have in the exponential statement is 4. So we have base 4. Okay. And whatever you have on the other side, you write along with the log, which is 5th root of 4. This is all. And make sure to practice. Okay. You have the 2 questions. One question you have to convert log into exponential, and the second question is you are converting exponential into log. Now, does anyone need more example for this type? Okay, now let's see what we have. In number 33, 34, and 35, we are asked to evaluate each of these expression using without using calculator. Okay, so here let me do 33. So we have log of 625 to a base 5. Okay, you can use your calculator to check your answer, but you can't write your final answer using your calculator. You won't get the credit. Okay, now here you need to use the log properties. So here, so we have log. So the base for this log is 5. Now you try to rewrite this 625 in terms of base 5. Now, how can we rewrite 625 with base 5? Or like, how can we rewrite 625 in an exponential form? So 625 is the power of, what power of 5? So is it the 5 times 5 is 25 times 5 is 125. Is it the fourth power of 5?
Yes.
600, yes. Okay, good. Now here, now we use the property. So we have this exponent 4. So we can write this exponent in the front of log. So we have 4 times log of 5 to our base 5. Now, what is log of 5 to our base 5? Now, here you have a 5, you are finding a log of 5 and the base is 5. If this is the case, what will be the value of this expression? It is always equals to 1. Okay, so in general, if you have a log of a to a base a, this is always equals to 1. So we have 4 times 1 and this is 4. And you can use your calculator to check this answer. But I need to see this work, okay? In 34, we have, I think 34, okay, let me do 34, 35 you should be able to do. So in 34, we have log of 6, so no, log of 1 over 36 to a base 6. Now, concept is same. You're gonna rewrite, our base is 6. You're gonna rewrite 1 over 36 in terms of 6, okay, with a base 6. Now we have log of, so we have 1 over 36 and 36 is 6 square to a base 6. Now here, we are not ready yet, okay? Now our base is 6 here, but the base is 1 over 6 here. 1 over 6 and 6 is not same. So 1 over 6 square is same as, we can write this expression in the numerator by changing the sign of exponent. So we have log of 6 to the power minus 2 to a base 6. Okay, so we had in the denominator, and whenever you are writing this expression in the numerator, you're gonna change the sign of exponent. If it's positive, you're gonna make it negative. If it's negative, you're gonna make it positive. Now we have a same base. We have a 6, we have a 6. Okay, and let's rewrite this exponent in the front. So we have negative 2 times log of 6 to a base 6, and this expression is 1. So we have negative 2 times 1, which is negative 2. Okay, does anyone have any question? 35 is log of 81 to a base 9. Okay, you should be able to solve. Now, any question of this type?
Can we do 37?
Okay, 37. Okay, let's do 37 then. So we have log of square root of 10. Now, what is the base for this log? It does not mention here, right? Now, what does that mean for us?
All right, I thought this was 4.4.
Okay, can you repeat that?
I thought this was 4.4, so I guess not 37 if it's not necessary. I don't. Yeah.
Oh, okay. So from okay, now let's wait for that. Okay. Okay, is 37 in the review? Okay, it's not, but okay, we started. Let's do this one. So here we don't have. It does not write any base, and if we don't have any base, if we don't see any base, what do we understand? What type of log is this? This is a common log. Okay, and common log has a base 10. Okay. I mean, you can just write when you are solving. So if you don't see any base and you have a log, that's a common log. And sometimes you might see ln, okay, and this is the natural log. So this ln is same as log to a base e. If you have a log without writing any mentioning any base, this is a common log, and this is same as log to a base 10. Now we have this radical 10, so let's rewrite that. So we can rewrite this. We need to get rid of this radical sign. So this 10 has exponent 1. The index for this radical is 2. So we write this 2 in the denominator here. So this is square root of 10 is same as 10 to the power 1 divided by index 2. Okay, so we have this exponent, we write in the front. We have 1/2 log of 10 to a base 10. This is 1. And we have 1/2 as our final answer. Okay, any question? Okay, I think this is all from our section 4.3. So next one is 51, 52. Let's see where we have. Oh, no, we have. Oh, yeah, it's 4. No, this is still 4.3. Okay, so we have 51 and 53. 51, sorry, 51, 52, 54. 51, 52. Okay, now here, yeah, is it okay if I now here we are solving 51, 52, and 54. So here we are given a function and we are asked to use the transformation like the very similar to one that we had earlier to graph this function, write down the domain, range, horizontal asymptote, vertical asymptote. Okay, so let me pick one. Let me do 51. So our function is f of x equals to log of x minus 6. So this is our function. We need to graph using transformation. So this is a log of x to a base 10. Okay, this is a common log. So your basic function is y equals to log of x. Let's graph this function. And you should be able to graph correctly. The shape has to be correct. I mean, I don't want perfect graph. And now if you have a log function, our graph looks like this. So this is a graph for our basic function. And what is the x-intercept for this graph? How do we find x-intercept? So you should also know what the x-intercept, and it will really help you to graph. You should be able to find the x-intercept. So finding x-intercept means finding what? So like if we are finding x-intercept, what do we know about that point? We know y coordinate is 0, right? Now in this basic function, so we have y equals to log of x. Let's substitute y equals to 0 and solve this equation for x. So the base is 10 here. Now let's write this in terms of exponential form. So you are starting from here. So our x equals to, so base is 10, and whatever you have on the right side will be the exponent. So 10 to the power 0. And what is the 10 to the power 0? 1, right? So this is 1 here. 1 is the x-intercept. Now we need to have a -6. So we subtract -6 from this function. So we have y equals to log of x minus 6. Now what does it mean by subtracting a function? If we subtract any number to a function, means we are shifting our graph vertically down by 6 unit. So -1, -2, -3, -4, -5, -6. Okay, so you use this as a reference point. Okay, so we are here, we are shifting 6 units down. So this is 1, 2, 3, 4, 5, 6. So you're gonna have this point over here. Okay. So this will be here, and this is our graph. And you can, like, if you are interested, you can find the x-intercept. Okay, what do? You substitute 0 and solve. Otherwise, you are not required. Now, for this graph, what is the domain? Tell me the domain for this function. Like, how far can we extend this graph on the left and right? Can we extend the graph all the way to the left? So like when you extend on the left side, it goes all the way to the down. I mean, it never crosses this vertical line. Okay, so we can't have any graph on the left side of this y-axis. There is no graph. But if you extend on the right side, we can go all the way to the positive infinity. So the graph will have a domain from 0 to positive infinity. This graph never touches this x equals to 0, which is y-axis. So parenthesis. What about range? What is the range for this function? Anyone, please? What do you think?
-infinity to positive infinity.
That's right. So when you extend the graph on the left, it goes all the way to the down from -infinity. And if you extend on the right, it goes all the way to the up. So all real number. Now, what kind of asymptote do we have here? Horizontal asymptote or vertical asymptote?
Vertical asymptote, y equals 0.
Y equal to 0 is a horizontal line. That is not a vertical line. X equals to 0. Okay, so this y-axis is our this line is our vertical asymptote. Okay, and this is x equals to 0. So every vertical line has your equation is start with x equals to, and where you have vertical line, we have vertical line at 0. So x equals to 0 is vertical asymptote, no horizontal asymptote. Now let's write the end behavior. As our x goes to positive infinity, our function is f of x. As we go all the way to the right, our y value also goes to positive infinity. As our f of x goes to negative infinity, it means as our f of x goes to negative infinity, our x goes to negative 0, close to 0. Okay, it means when your x is equals to, when x is very close to 0, your graph goes to negative infinity, and this is the end behavior. So you will have, okay, one question where you have to use the transformation to graph the function and write all these domain range, horizontal asymptote, vertical asymptote, and the end behavior. Okay, now you do have two more to practice. Okay, is it okay if I skip?
Yeah.
Okay, now let's go to the next if so we did 54. Now so we have 62, 63, 65. Okay, now we are sections 4.4. So number 62. We have to, okay, we have ln, this is the natural log of cube root of x to the power 5 and square root of y cube. And we are asked to rewrite this expression as a sum or a difference of log expression. And we need to use the log properties. You will be given the log properties. Okay, okay, let me double check. I think you should have the log properties on your exam. Let me double check. Okay. Okay, did you all go through the additional Proctorio instruction that I made an announcement? Does anyone have any question on that instruction? Make sure to follow the instruction very carefully, okay? You should follow every instruction. So the very first instruction is that make sure that you are recording your desk for whole time during your exam. Okay, I won't mind if I don't see your face. It's okay if I do, since you will be asked to have your ID and picture taken, so I won't mind if you don't have a picture of video of yours, but I need to have a record of your desk, okay, during your exam time. That's the very first one. And the next, so what we had, so yeah, the next one, okay, the properties are provided to you. Okay, and the next one, I think you should, yeah. So before you start your exam, you should show every scratch paper, both sides, before you start your exam. Okay, and once you have your every scratch paper recorded, you are not allowed to add any extra scratch paper. So make sure to show all the scratch paper. And the next, now I know you have 2 hour time, okay, and you have like 10 question, so you should have enough time. And like once you finished each problem, you have to show that you completed that. Okay, you finish one, you just show to the screen that you completed one. You start two. Once you complete two, you show your answer to the screen. Okay, complete after completing two, and you should have enough time. Okay, it's 2 hour. And the next one, at the end when you complete your exam, you have to take a picture of your work, and that activity, that taking a picture, it has to be also recorded on the video. Okay, so make sure you follow this instruction. And if I don't see this instruction, then there might be deduction. Okay, there will be a deduction on your points. And I'm pretty sure that 2 hour time should be enough for you all to follow this instruction. Okay, does anyone have any question on this on this topic?
I have a question.
Yes.
If we end up changing our answer after we show it to the camera, can we just show it again and then say
No,
that
you are not required. Like, I mean, it's okay to like, you might need to change. Yeah, you might need to change. But in that case, you are not required.
to show it again?
Yes,
Okay.
just once. Okay. So let's go to the next one. Okay, no. Let's finish number 62 first. So here we are asked to rewrite this log expression using sum or a difference. Okay, And whenever you see the radical sign, you have to get rid of radical sign. Okay, we don't like radical sign here. So the very first step is getting rid of this radical sign. We have a cube root, we have a square root. So let's rewrite this without radical sign. We have ln, and to rewrite, how do we get rid of radical sign? We use this index to divide our exponent. Okay, so we have a 2 here, so you divide this exponent 3 by 2. So we have x to the power 5 divided by 3 times y to the power 3 divided by 2. So your denominator is the index. Okay, so this is the first step. If you have a radical expression, get rid of radical sign. Now the next here we have ln of x to the power 5 over 3 times y to the power 3 over 2. Now if we have log of m times n, this is the sum of log expression. So plus log of m plus log of n, and this formula will be provided to you. So let's use this formula. We have ln, so we're going to use ln of this expression, x to the power 5 over 3. Since it's a product, we have a plus. Now again write ln of y to the power 3 over 2. Okay, if you have a log of product, then you get sum of log. If you have log of quotient, you get the difference of log, log of m minus log of n. Now we have the exponent. Now this x has exponent. Okay, so if we have exponent, we can write this exponent in front of ln, and same property for this second expression. So we have 5 over 3 ln of x plus 3 over 2 ln of y, and this is our final answer. So we are expressing this log expression as a sum of log. Okay, any question for number 62? Okay, 63, 65. If you don't have, then let me choose 63 and 65. Okay, do you want to pick from 63 and 65? Both looks very similar. Okay, and I will do one. Okay, if you're not picking, then I'll pick myself. So let me do 63. So we have log of square root x to the power 6 divided by y cube g to the power 5 to a base a. We have a radical sign, so let's get rid of this radical sign. This radical sign has an index 2. Now you are using this index to divide every exponent. So here divide by 2, divide by 2, divide by 2. So this is log of x to the power 6 divided by 2, y 3 divided by 2, g 5 divided by 2. Okay, and you do this if you have a product or division, then you are using the same index to divide the exponent. Okay, but for example, if you have something like x square plus y square, how do you get rid of radical sign here? Who can tell me to rewrite this expression without radical sign? It's not the same as we just did. Okay, we have a positive here. If we have a positive or negative, then we just take this as our one term, and this has exponent 1. The index is 2. So we take this index 2 here, and we have x square plus y square to the power 1/2. Okay, it's a different. Okay, whenever you have a product and division, the index is for each term. Now whenever you have positive or negative, we take that as a one expression. Do you have any question here? Okay, so we have log x 6 divided by 2 is x cube divided by y3/2 g5/2. Now here we have a log of exponent, log of, this is the numerator and this is the denominator. And if we have a log of exponent, see, if we have a log of exponent, then this is equals to difference of log of numerator and log of denominator. Now let's do that. So this is difference of log. Oh, I forgot to mention base. Okay, base remains same in each step. The base does not change. Okay, so we have the difference of log. You write down the numerator x cube, write down the denominator y3^2 g to the power 5/2. Now we have this exponent right in front of log. So we have 3 times log of x to a base a minus. Now again, so here we have log of y to the power 3/2 times g. So we have a log of product. And if we have a log of product, we will have a sum of log. Okay, we're gonna get it 2 terms. So make sure to have parentheses. Since we have a log of product, we're gonna get sum of log. Log remains same. So log of y to the power 3/2 plus log of g to the power 5/2. Okay, now here 3 log of x to a base a minus, you can distribute negative, and we have this exponent we can write in front. So negative 3/2 log of y to a base a, negative times positive negative, you have exponent, you can write in front 5/2 log of g to a base a. And this is our final answer. You will have one type of question where you will be asked to rewrite single log expression as a sum or a difference of log expression. And in the similar way, you should be able to do number 65. Can I skip number 65? We have ln of cube root of x y cube over g to the power 5. And I want you to practice this 65. And if you still need help, just write me an email, okay? All right. No question? Okay. Let's see what we have next here. 65, 68, 70, 72. 68, 70, 72. Okay. Now here in 68, 70, 72, we are given more than one log expression. Okay. And we are asked to write as a single log expression. And you will have one type of question out of this 68, 70, and 72. So 68. So we have log of x squared minus 4 to a base a minus log of x plus 2 to a base a. It does tell us what is a. A has to be greater than 0, a not equals to 1. And we don't really need to worry about this one. Now we have two log expressions. See, so this is the one log expression and this is the next log expression, and we have to rewrite, which is the just reverse of these examples, okay, the one that we just did. Now here, what do we have? We have a difference of log. So we have a difference of log. And what is that difference of log equals to? So if we have a difference of log, then this is equals to log of exponent. That's what we're going to write here. So this is log of exponent. First is your numerator, x squared minus 4, and the next is your denominator, x plus 2, base is a. Now here we can factorize x squared minus 4. Okay, we always need to have our answer in a simplest form. So this is log of x squared minus 4 is same as x plus 2 times x minus 2 divided by x plus 2 to a base a. x plus 2 common factor, cancel out. So we have log of x minus 2 to a base a. And this is our final answer. We had a 2 log expression and we end up having a single log expression. Any question? Okay, now out of 70 and 72, let me do 72, okay? And I want you to practice number 70. So in 72, we have 2 times ln x squared plus 1 plus 1/2 ln x to the power 4 minus 3 ln x. Now, so here we have a sum of log and difference of log. Now, can we use sum of log for the first two expression? What do you think? Like, we have a sum of log. Can we use this property, like whenever we have a sum of log, we can write as a log of product? What do you think? Can we do that here? Or we need to have extra work before we use that property?
Needs a base of 1.
The coefficient has to be 1, not the base. Okay, the coefficient. Okay, now here the coefficient for this log expression is 2, and this is 1/2. So we need to have always 1. Okay, like if we go back here, see on the formula there is always 1. Base can be any. So here is 1, here is 1. So always try to make 1. Okay, now we need to get rid of this 2, and for that we can take this back. Okay, we can write this 2 as exponent of this expression, and this half we can write an exponent for this expression, and similarly this 3 can be taken back to the exponent here. So this is ln x squared plus 1. Okay, this 2 you write as exponent plus ln x to the power 4 and write 1/2 as exponent. 1/2 is exponent minus ln, write these 3 as exponent, x cube. Do you have a question here? Okay, now our coefficient is 1. Now we have a sum. Now, yes, we can use that property, and according to the property, we can write this as a log of product. So you write this expression, x squared plus 1 squared times this expression. X squared 4 times 1/2 is 1/2. So you can simplify, minus ln of x cube. Now we have a difference of log. And if we have a difference of log, we write this as a quotient. So this expression will be the numerator, x squared plus 1 squared times x to the power 1/2 divided by, this will be your denominator, x cube. Okay, and the last, if you have a rational number as a fraction, if your exponent is a rational number, you can write this using a radical sign. Okay, if you have a rational fraction, if you have a rational exponent, this is ln x squared plus 1 has a whole number as exponent, x to the power 1/2 is same as square root of x divided by x cube, and this is our final answer. This is how we rewrite in a single log expression. Does anyone have any question? And we are done with section 4.4. Okay, now let's go to section 4.5. So 4.5, so we did 72. So 73, 74, 76. Okay, 73, 74. Okay, so here 73, we have 5 power x equals to 625, And we are asked to solve this equation, and this is our exponential equation, okay? And there is a two methods. Whenever you have exponential equation, you have a two method. The first method you gonna try, the very first thing you're gonna try is that you try to make a same base on a both side. If you have a log expression, if you have a exponential equation, then you always try to make a same base, okay? For example, if you have a to the power x equals to a to the power y, we have a exponential expression with a base a equals to another exponential expression with the same base a. If this is the case, then this equation implies the exponents are equal. We can write x equals to y. Okay, so every time if you see exponential equation, always try to rewrite with the same base on a both side. That should be first step. Now here we have 5 to the power x. Now is there any way we could write 625 as a base of 5? What is 625? It is 5 to the power 4. We have a same base. If you have a same base, then the exponent is equals to each other. X is equals to 4. This is the final answer. Okay, you always try to write using the same base. In 74, we have 6 to the power 2x equals to 1296. Now, is there any way we could rewrite 1296 as a base of 6? I think we should be able, right? Okay, what is 1296 in terms of 6? 6 times 6, 36 times 6, 216 times 6. Yeah, 6 to the power 4. So 6 to the power 4 is 1296. We have a same base, so we can write our exponent 2x equals to 4. This is a linear equation. You divide by 2, your x is 2. And this is our final answer. Okay, let me know if you have any question. This is the one type where you can have same base on a both side. You just equate your exponent. Now in 76 and 79, okay, 76, okay, let me do 76. 4 times e to the power x plus 6 equals to 38. Okay, so we have a like terms here, so let's collect like terms. So we subtract 6 on both sides. 4 e to the power x equals to, this is 0, 38 minus 6, 32. Now we have 4 in front of this exponential expression, so let's get rid of 4 by dividing by 4 on both sides. E to the power x is 8. Now, can we have a same base on both sides? On the left, we have base e. Now, is there any way we could write 8 with the help of base e? E to the power of what number equals to 8? Can we do that? Okay, now here, we don't get the whole number as exponent. Now, if this is the case, what are you gonna do here? We're gonna apply log on both side. Okay, now here base is e, so if you have a base e, you take natural log on both side. Okay, if you have base e, you take natural log. If you have base 10, you take common log. Okay, and if you have other base, it's okay if you take natural log or a common log, it does not matter. Okay, so you're gonna apply any log or natural log on both side. It really doesn't matter. Now the reason I choose natural log here is we have a base e. Okay, it will be easy for us to simplify here. Now we have this exponent. Now let's bring this exponent in front of log. So we have x times ln of e equals to ln of 8. Now who can tell me what is ln of e equals to? What is ln of e? What is the base for ln?
1.
Yes, the base of ln is e. So we are finding log of e to a base e, so this is 1. So x times 1 equals to ln of 8. So our x is ln of 8. And this is our final answer. And you will have this type of equation, okay, where you will be required to apply log on a both side, or you will also have an equation where you are required to have a same base on a both side. Okay, and these are the two way to simplify your exponential equation. Try to make a same base on a both side if you can, and if you can't make a same base on a both side, you're gonna apply common log or natural log, and you can pick any log. It does not change the solution. And as I said, if you have a e as a base, then I want you to use natural log. If you have a 10 base, I want you to use the common log. Okay, so 79. I want you to try 79 by yourself, okay? In 79, just let me write down the problem here. So we have 4 to the power 2x plus 3 equals to 16. You can write 16 as a 4 square. So we have the same base. So this expression equals to 2. So 2x plus 3 equals to 2. You subtract 3. 2x equals to -1. Divided by 2. X equals to 1/2. This is your final answer. Okay? This is 79. Do you have any question? Okay, then the next 87, 89, 91. 87, 89, and 91. Okay. Oh, there's nothing to practice from 46. Wow. Okay. I think it should be good. Yeah. So there is nothing to practice from section 4.6. Okay, now these three are our log equation, and you'll have, I think, 1 or 2 log equation to solve. So 87, here we have log of x plus log of 2x minus 1 equals to 1. So this is our 87 log equation, and we are asked to solve this equation. Now, what is this first step whenever we are solving log? Does anyone recall this very first step of solving log equation? We always need to collect our log expression in one side. Okay, that's what we have here. So all log expression is one side, and we will rewrite all log expression in a single log. Okay, now we have to rewrite this right side using a single log. That's what we did earlier. Okay, now we have a sum of log. So if we have a sum of log, we can write this as a log of product. So log of x times 2x minus 1 equals to 1. So always try to collect all log in one side and rewrite your log expression using a single log. Okay, now once you have a single log, you're gonna rewrite this log expression as an exponential expression. Okay, first step, collect all log in one side. Second step, you're gonna write all the log expression as a log as a single log. Then you rewrite this log expression as an exponential. Now you convert this into exponential equation. So you're gonna write whatever you have here. So we have x times 2x minus 1 equals to base. What is the base? This is a common log. Common log has a base 10. So we have a 10 base, and whatever you have on the right side is the exponent 1. So you distribute this x times 2x square, x times 1 negative x equals to 10 to the power 1, 10. Now this is the quadratic equation. We all know how to solve this one. So you subtract 10, we have 2x squared minus x minus 10 equals to 0. You can use quadratic formula, you can use factorization or any method. So let me use quadratic formula, minus b plus minus b squared minus 4ac divided by 2a. Your a is 2, b is negative 1, and c is negative 10. So b is negative 1, so we already have negative, so positive plus minus b square. B is negative 1, square of negative 1 is positive 1, minus 4 times a, 4 times 2 is 8, 8 times minus 10, that is negative 80 times negative, we have positive 80 here, divided by 2 times a is 4. This is 1 plus minus 1 plus 80. 81 square root of 81 is 9 divided by 4. You take positive 1 plus 9 divided by 4. You take negative 1 minus 9 divided by 4. So we have 1 plus 9, that is 10 divided by 4, negative 8 divided by 4, which is negative 2. Now, can we have a negative answer here in our equation? Let's check. So we have log of negative number. Now, is log of negative number defined? What is log of negative number? The domain has to be always positive if we have a log function. We can't have a negative number, okay? So this is not the solution. So our solution is this one. Okay. Question for me. Okay. Now let me do 89, and 91 is very similar to 87. So I want you to practice 91. So in 89, we have log of 3x plus 1 minus log of x squared plus 1 equals to 0. First step, you are collecting log expression in one side. That's what we have. Second step, you are rewriting in a single log. So we have a difference of log. And if we have a difference of log, this is log of exponent. So this is your numerator, 3x plus 1, and this is your denominator, x squared plus 1 equals to 0. So you have a single log. Next step, you are converting this log equation into exponential equation. So you're going to write whatever you have here. 3x plus 1 divided x squared plus 1 equals to base. Base is 10 here. 10 to the power whatever you have on the right, which is 0. So this is 3x plus 1 divided x squared plus 1. 10 to the power 0 is 1. This is a rational equation. Okay, we need to get rid of this denominator x squared plus 1. So we multiply both sides by x squared plus 1 so that we won't have denominator, it goes away. Now we have 3x plus 1 equals to x squared plus 1. This is a quadratic equation. So let's collect all these terms together. Subtract 3x, subtract 1. So this is gone, 0, x squared. This is gone, minus 3x. And you can use a factorization here because x is the common factor. X minus 3 equals to 0. You set each factor equals to 0. X equals 0, x minus 3 equals to 0. We have this, x equals to 3 from here. Now you have to check whether these two are solution or not. Okay, yeah, both are defined. So these two are the solution for this log equation. Okay, any question for me? I think we are done here. Does anyone have any specific question? I think who asked me number 37? Did we do that number 37? I think it was from section
I think yeah, I think it was from one of the assignments. But
Oh, from the
I don't know.
homework only?
I think we might have covered it. But yeah, I was just not getting the right answer for that one.
Okay. Now, do you still need help? Did you get some idea on that? Can you do it by yourself?
I think so. I think some of the ones you went over were the same format.
Ah, okay. But if you still need help, just write me an email, okay?
Okay.
Now, does anyone have any question? We are done here. So these are the problem that you're gonna practice, okay? And make sure, one more time, I'm telling you, make sure to follow the instruction very carefully, okay? You have plenty of time, you have enough time. So make sure to follow the instruction and practice the review. And if you practice this review, it should be enough for you. And you all know that I mean, you're one of the lowest test grade has already been dropped. Okay. I'm not encouraging you not to take test for, like, just if you plan to drop this test, then you are not required to take test this exam 5. Okay. Like if you have first 4 exam with a like a full points, and if you think, I mean, if you want not to take exam 5, it does not change your grade, but I'm not encouraging you. I want you to take this exam, okay? It will be your review or practice for your final exam. But just in case if you decide not to take, it's okay. If you don't take this exam 5, this one will be, you get the 0. It means this will be the lowest score you're gonna have, and it will be dropped. But that's not what I'm encouraging you here. Okay, I'm just letting you know that this is also the option if you are thinking, if you are not in position to take exam, then this can be also an option for you. Okay, let me take any question if you have. If not, we are done here. I will end this meeting and upload the video on the Canvas. Does anyone have question?
So if we take the test, it will be added to our grade, whatever score we get.
Now, okay, now if you take this test, now you will have a 5 unit exams grade, right? And out of that 5, one will be dropped. It might be exam 5, exam 1, or whatever lowest score you have, that will be dropped.
Okay, thank you.
Mm-hmm.
Do you know which future exams? I think there's only 2 left. Have extra credit on them.
Okay, this one does not have extra. Oh, it does have extra credit.
Does it?
If you read the instruction carefully, you're gonna get the 4 points. So, like exam 1 and 2, I have the multiple choice question, which you have to answer on the base of the instruction that you have to follow during the proctoral exam. So you have like a 4 point as a bonus point. Yeah, you have that 4 points, and on the final, yeah, on the final you'll have bonus question as well.
Okay. And then for that one, I see that the overall grade is 104. Is that 4 points on top of that 104, or is that 104?
Okay, 100 is the, okay, 4 point is the bonus point.
Okay, gotcha.
So total point is, okay, I think I need to, okay. Oh yeah, I need to make change that. Yeah, 4 point is the bonus point, and the total would be 100. Okay, I'll update that. Thank you for letting me know that. Okay, I have to change that then. Yeah.
Yeah. Okay. Cool.
All right. If you don't have any question, I'm gonna end this meeting, and I wish you good luck. And if you have any question, just write me an email. Okay. Have a great night. Have a great exam, and bye bye.